Hi, this is Mr. Cure. This video, going to be looking at the difference between physical changes and chemical changes. So what I have here is I've got a beaker full of water. And if you recall, water is a polar molecule, which means it has charged ends. So in this case, it has partially positive ends and partially negative ends. And this is due to the unequal sharing of the electrons between the oxygen and hydrogen. Oxygen has a higher electronegativity, and therefore it's going to attract electrons a little bit more, making the oxygen end slightly negative. Well, I also have this molecule up here. This is glucose. And glucose is also a polar molecule with a variety of negative and positive charges. And what it's going to do is it's going to interact with the polar water molecules, and the glucose is going to dissolve. So let me show you what happens with that. So if I put glucose in here, what's going to happen is these glucose molecules are individually going to be interacting with water molecules because of their polarity, and they're going to form these intermolecular attractions between them. So this is what's happening in a physical change. We call this a dissolving process. We're simply mixing the two substances. There's no change in the water molecule. There's no change in the glucose. All that's happening is we've got these intermolecular forces that are interacting with each other. Another physical change would be this, where we've got water evaporating or changing state in other ways. So what we have here, I've got a single water molecule. Remember, the water molecules have these charged ends, and what's going to happen is there's interaction between this water molecule and water molecules around it. And as a result, we have quite strong hydrogen bonding occurring. So what can happen though is we can add energy to this water molecule, and if it has enough energy, it can actually overcome these intermolecular forces and break free and change into a vapor. So what happened was the water molecule is still intact, nothing changed, so it's a physical change, but because we have a change in state, we've overcome these intermolecular forces again. So both changes in state and dissolving processes are physical changes because there's no change in the overall molecules. Well, let's look at a great example of a chemical change. That's pretty impressive. And what that was the interaction of, or the reaction of hydrogen with oxygen. So what happens here is when these two gases react, the atoms actually separate in each of these molecules, and then they recombine to produce a new substance. So this is what happens in a chemical change. We have a rearrangement of these atoms with these new molecules, and what's happening is we're overcoming the intramolecular bonds. We're actually breaking the ionic or covalent bonds as a result. So when we're looking at chemical and physical changes, how do you know what's happening? How can you tell them apart? Well, these are some clues that you look for. When you have a chemical change, remember you're producing something new, and during that process you can produce or absorb heat and light. Oftentimes, because we're producing a new substance, a color change occurs as well. Or suddenly I'm producing a gas where we had two solids or a liquid before. So you've got bubbling or fizzing produced. And sometimes I've got two liquids, and we mix them, you produce a solid substance, a precipitate. So when you're looking for evidence for a chemical change, you look for these different types of elements, or these different types of clues, pardon me. So that's it. Hopefully you can tell the difference between chemical changes and physical changes.